The best way to do is to treat everything like it's positive, okay? So the first thing you should do is treat everything like it's positive. Okay, that's the number starting point of the whole thing is treat everything like it's positive. So when I say treat everything like it's positive, when I look at number 1 and it says -2 angle 7 pi over 4, what I'm saying is that I'm going to treat this like a positive 2. I'm going to go out 1, 2, and then I'm going to go to angle 7 pi over 4. Well, where's 7 pi over 4 located?
315 degrees.
315 degrees. So that means I would come around and I would be right here, right? Okay, if I was a positive point, that's where I would be. But I'm not positive. Well, I'm a positive angle, but my radius isn't positive. Because my radius isn't positive and we're using the graph, what this means is that mathematically, I'm going to subtract 180, but just graphically, I'm going to go diagonally. Okay? Mathematically, I would subtract 180. Graphically, I'm just going to go diagonal, and this is where my home is. And that's where A lies. Do we kind of remember that?
Yes, ma'am.
Okay, again, on number 2, we're going to treat everything like it's positive. So I'm going to go out to 3. 1, 2, 3. So I'm right here. And I'm going to go to angle 2 pi over 3. Well, angle positive 2 pi over 3 is right there. Okay? Because it's a negative angle, what this means is that I am actually going to reflect over the x-axis. Okay, when I reflect it over the x-axis, mathematically what I'm doing is saying how far am I away from pi, which is 180, right? How far am I away from pi 180 in this quadrant? And when I reflect, I need to be that same distance away from it in the third quadrant. So when I reflect from here, I'm going to end up here, and this is where I lie.
Only
When the angle is negative.
the water.
It's not a y value, it's your theta value. It's an angle value. Okay? So, when I have a negative radius, mathematically that means I am adding or subtracting 180, right? Okay? When I'm looking at it graphically, that means I'm going diagonal. Capiche? Alright. 2, when I am a negative, I'm going to act normal. Graphically, that means I'm reflecting over the x-axis. Mathematically is I'm maintaining the same reference angle from my x-axis. So if I'm 60 degrees from here, when on the negative version, I will be 60 degrees from negative 180. It's all about reference angles. Okay, that's why we learned about reference angles. Reference angles, remember, are how far are you from the nearest x-axis value. So how far are you from 0 if you're in the first quadrant? How far are you from 180 if you're in the second and third quadrant? How far you are from 360 if you're in the fourth quadrant? Excuse me? Yes, ma'am? Hey. Okay. He was actually going to be the one that rides the bus because he's fine. Because he only has one. His kids are the only ones that actually act in the morning. So when his kids are done, him and his kids can leave. So then they would ride back and pick up the afternoon group of kids. So he was fine. He could drive. He could drive or he could ride the bus. He's one of the ones that are fine. Yeah. Okay. Got it. Yes, ma'am. Yes, thank you. No,
You're still talking.
I don't know. All right, so now we're on to C. Now, what do you notice about C?
They're both negative.
They're both negative. Okay, because they're both negative, what you're going to do is you deal with the angle first. You do the angle first, and then you do the radius second. Okay? So I'm going to deal with the angle first, and then I'm going to do the radius second. So that means, in essence, I would reflect first, and then go diagonal. Cool? All right, so we're going to treat everything like it's positive. So 5, 11, pi over 6. So I'm going to go out 1, 2, 3, 4, 5. I'm going to go all the way around, So 11 pi over 6 is 330. So I'm right here. So if I was positive, I would be right there. When I'm not positive, I'm actually both negative. So the first thing I need to do is reflect over the x-axis. So I'm going to end up over here. And then after I reflect over the x-axis, what I'm going to do? Go diagonal, and I end up here.
Is there any trick to this?
That's it. Those are the only tricks. Okay, on your test, what's going to happen is the points will be plotted for you. And you just have to tell me where they're located. Okay, the points will be plotted, and it's multiple choice, and you tell me which ones represent that point. Okay, so what we're going to do is we're going to practice identifying points, because if you know how to plot a point, then you should know how to identify a point. Yes?
So I'm confused. Like on number 7, so basically just putting.
We haven't gotten there yet. That's why you're confused.
And you see the process of 330 minus 180 gives you 150, then you do the thing cross farming, which gives you the same answer.
Yeah, to get the diagonal value.
Yeah.
Yeah, but you wouldn't do the subtraction part first. You would do the angle part first. That's why we say we focus on the angle. So if I'm at 330, then how far am I away from 360? 30 degrees. So when I reflect it over, I need to still be 30 degrees. And then from this point is where I would add the 180.
So you can add 180.
Yes, you would add 180 because I need to be within the circle. You can subtract it too, and it'll take you to the same place. All right, so 4, 5, and 6 are for you to do on your own. The answers to all your problems are on the back and on the bottom. The reason why I gave you the answer is because I want you to do the problems, and I want you to check to make sure that you're doing them correctly. Okay? I want you to do the problems, and I want you to check to make sure you're doing them correctly. So I gave you the answers. So I will not be collecting your review for a grade. It is strictly for you to review and practice.
How long is the test?
How long is the test? Your test is 11 questions?
Oh, man. So you got 20 minutes.
No, you have the whole class period.
So it must be hard.
It's really not.
We still on the track. Schedule you gave us.
I have a new one to give you tomorrow.
I just had it.
No, we have a new one tomorrow. You'll see.
Cut down again.
Yep, we got further behind. All right, so number 7 we're going to do, and then number 9, we're just going to write a little special 10, because I should have put a 10 here.
But isn't 10 on the.
That's why it's a special 10, Don. I put a little asterisk by it. I don't know if you heard those words come out of my mouth, but they did. All right, so what we're going to do is we're going to do 7 and special 10 together. Okay, and I'm going to leave you 8 and 9 to do. Got it? All right, so with 7 and special 10, what we're doing is, I need to zoom in. We're identifying the points. For every point, there are actually 4 ways to name it. For every point, there are 4 ways to name it. Okay? The point, 4 ways to name it between negative 2 pi and positive 2 pi. Let me be very specific. There's numerous ways to name it, but between negative 2 pi and positive 2 pi, there are 4 ways to name it. Does that make sense? Okay, so my restriction is I cannot be smaller than negative 2 pi, and I cannot be larger than positive 2 pi. Got it? All right, so with these 4 things, 2 of them will have a positive radius, and 2 of them will have a negative radius. Okay, 2 will have a positive radius, and 2 will have a negative radius. So when I look at P, what would be my positive and negative radius values? 3 and negative 3. So I will have 2 of them that will have 3, and 2 of them that will have negative 3. Okay, that's the easy part.
That's just because of 3.9.
Do it matter which one you go?
Excuse me?
Does it matter which one you go?
No. Well, I'm going to do the order that makes it easier. Okay? So the order I go in to solve these problems, I feel like is the easiest way to do it. The first thing to do is find the positive. So when I look here, if I'm here at positive 3 as my radius, and I would go around, what angle would this be?
It will be
7 pi over 6.
7 pi over 6. So my positive angle is 7 pi over 6.
What's your name?
Okay? So my positive angle would be 7 pi over 6. We got it? We're good? Alright. So then the next thing that I feel like is easier to do is to find your negative positive angle. Okay? So to find your negative radius positive angle, what you're doing is, if I was to make this diagonal, so if I was to go diagonally from here,
it will be power.
I don't think I went diagonally very well.
Power 6.
Is that right? Is that 3? Yeah. Alright, and I get what?
Power 6.
Pi over 6. So my diagonal would be pi over 6. Okay? So let's recap what we did. We went from here to here by finding the diagonal. Got it? Alright. Huh? So on the other ones, what you're doing is you are finding its reflections. And because I'm reflecting, that makes them negative. So if I was to reflect 7 pi over 6, what does it land on? If I reflect from here to there, what is this value?
135.
It would be 5 pi over 6, right? It would be 5 pi over 6. If I'm reflecting this point over the x-axis, it comes right here. And this is 5 pi over 6. But because I reflected, it's going to be a negative 5 pi over 6. So to find this one, we, reflect it. Okay? You're going to do the same thing here. So to find this one, you're going to reflect. So if I'm at pi over 6, I'm going to, and I reflected, so it's a negative 11 pi over 6. Okay? If you don't like the reflecting, then you also could go diagonally. I can say if I'm at 5 pi over 6, when I go diagonally, I'm going to end up at 11 pi over 6. And it's negative because I...
So, if you were doing this without multiple choice, okay.
If we were doing it without multiple choice, there would be 4 answers. So when you're looking at the multiple choice, if you don't see the positive one, that means that it could be one of the other 3.
So, and on each multiple choice, you're going to have, well, not all of them, but the one that's going to be correct is 2 negatives, 2 positives.
It could be any of them. It could be the one with 2 positives. It could be the one with 2 negatives. It could be the one with 1 positive and 1 negative. It's just you have to know how to find all 4 so that you pick the correct multiple choice.
But you just showed us something.
Exactly. So as long as you know how to find all 4, you should be able to eliminate the...
How simple, like, look what, ooh, you be telling us wrong when we start this stuff.
I'm saying the same stuff all over.
Let's go. So you better go on.
Yeah, you're right. I made up a whole new lesson over spring break.
You did.
You're right.
Cause you do stuff like that. Well,
Yeah. Purpose of a review is to recap, but
Hold on, we doing 9?
we're gonna do 10, special 10. Remember? All right, so we're doing special 10. Okay, so on. Because I drew it in, Don. Special. That's why. So we're doing special 10. Now, the key thing with special 10 is you're going to use the positive angles. Okay? You're going to use the coordinates with the positive angles. And these are my coordinates with my positive angles. Okay? You're going to use the coordinates with the positive angles. Does that make sense? Okay. So keep that in mind. So now what it's telling me is that it wants me to expand on my restriction. So instead of being from negative 2 pi to 2 pi, it wants my angle to be between 2 pi and 4 pi. So what that means is that I had to have gone around the circle a second time, or attempted to go around a second time. Okay? And remember, that means I'm either going to add 2 pi or I'm adding 360. Some of you guys prefer degrees. I prefer radians because they're smaller and easier to manipulate. And I'm lazy. So, what can happen is that you'll end up with 2 coordinates. One's going to be positive and one's going to be negative. To find their corresponding angles, you're using the positive angles from here. And with these positive angles, you're adding another rotation to them. Okay? You're adding another rotation to these angles.
So you just add 2 pi.
You just, exactly. So you're just adding 2 pi. So when I'm looking at the positive, my positive angle is 7 pi over 6. So I'm going to take 7 pi over 6, and I'm going to add 2 pi to it. They do not have like denominators, but can I make them into like denominators? Yes. I can do chopsticks in the bowl, or I can simply multiply both by 6. And I get 12 pi plus 7 pi, which is, if you do chopsticks in the bowl like Don prefers to, 7 times 1 is 7, plus 6 times 2 is, and my bowl is 7 plus 12 is still 19 pi over 6.
I don't know. I'm not very fond of chopsticks and little things.
Well, then just do common denominators. So you're not fond with either one, I see.
I look at it and know I can do it. It's been a minute.
Oh, okay.
It's been a week.
Let's see if we do it again, and let's see if your mind pulls it together. All right, so with negative 3, what's his positive angle? Pi over 6. So I'm going to use the pi over 6, and I want to go around one more time the pi over 6. So I'm going to add 2 pi. It's going to go over 1 because in order to add fractions, you both have to have a numerator and a denominator. If I was to do chopsticks in a bowl, you literally chop, stick 1. Pi times 1 is pi. My rice is addition. My other chopstick to eat my rice with is, and my bowl that holds it all together is, and what's 1 plus 12?
13.
That's chopsticks in a bowl. Okay? If not, then just use common denominators.
You can't reduce those, right?
Huh?
Like, if they were reduced, you can't reduce.
If it's reducible, yeah. But 13 and 6 have no common factors. All right, so how do we feel about finding the greater ones when I go around one more time? So think about it. If I was to go around 3 more times, then I would add another 2 pi, right? If I was to go around 4 more times, I would add another 2 pi. Okay, so you're adding on the 2 pi depending on how many times you keep spinning in a circle, because that's literally what you're doing. So when someone tells someone, oh, you made a full 360, I always question why they tell that person they made a full 360. Because 360 means that you tried to change and then you just came back to being your same old self. That makes no sense. Okay? That makes no sense. You tell someone, oh, you made a 180, because that means you changed from who you were. Or give them some other degree. But don't ever tell someone they made a full 360. Okay? Don't do that.
When you say add 2 pi or say 2 pi, theta,
Like if this range said from 2 pi to 6 pi.
so you put,
That means if I'm at 6 pi, that means I went around another time, right?
so I just put 6 pi plus,
No, so you would add another 2 pi. Because every time you go around a circle, it's 2 pi. Okay, so that's one rotation. And when I go around again, what's 2 pi plus 2 pi?
4 pi.
And when I go around again, 4 pi plus 2 pi is?
What I'm saying is that this, because we did 2 pi is like one, conventional circle. We had to do it again. It'd be 13 pi over 6 plus 2 pi again.
Yes.
So it'd do more work.
If it asked you to expand on it, yes. But I think I kept it like this. I didn't expand on it. It's only 11 questions.
My head started hurting. I thought I said this.
Maybe your head hurts because you wear fake glasses and it's a glare.
She stays true.
Oh, you don't say no, dog.
I'm not Malcolm X. I was just pointing out the facts.
Oh,
All right, so I'm going to leave you 8 and number 9. Okay, I want you to try them and then check your work later.
and
All right, moving on to the back. There's a back. For the people who did not take the quiz before we left for spring break, going over the back will help you for the quiz. So if you were not here and you did not take the quiz before spring break, so that means you weren't here Thursday and or Friday, then the back will help you get ready for your quiz. Okay? All right, so on your quiz, what's going to say, it's going to say non-calculator part and calculator. They'll be in little boxes just like this one. It'll say non-calculator in a box. When it says non-calculator, that means I want exact values. I want exact answer. Okay? If it's required to be in radians, that means you need to have pi in your answer. If it's using a square root, an unperfect square, then that means it needs to be underneath the radical. Okay? That is what exact values are. Now, the ones that say in the box calculator, that means you can give me the rounded decimal value. That's when you can round to the nearest hundreds. Just like your quiz you took on Thursday, the ones in parentheses said calculator, and you can write the decimals out. Same thing on your test. When it says calculator, that's where you can just plug it into the calculator and write down whatever the calculator gives you. Okay? Got it? All right. So what we're going to do is on number 10, we're going to do the non-calculator version, and then I'm going to show you on the calculator version. Got it? All right. So non-calculator version is we have to figure out which formulas we're using. If I'm going from polar to rectangular, so I'm going from these polar coordinates to these rectangular coordinates. What formulas will I use?
R squared, X squared, Y. No, it's the X cosine.
Then I would use x equals r times cosine theta and y equals r times sine theta. Okay? Those are the two formulas that I will be using to go from polar when I have r and theta to rectangular when I have x and y. Alright, so let's get to plugging in. So to find x, I'm going to do negative 10 times that's a huge C, the cosine of negative 7 pi over 6. Okay? This is where I'm going to use my unit circle at. I need to use my unit circle to find the cosine of 7 pi over, negative 7 pi over 6. So I'm going to go to my unit circle, and I'm going to find positive 7 pi over 6. Okay? This is where positive 7 pi over 6 is, right? But I want negative 7 pi over 6. What does a negative angle tell me to do? Reflect over the what? X. So this is actually,
150.
it actually is 150, right? So they're equivalent. Negative 7 pi over 6 is equivalent to positive 5 pi over 6. So because I know my equivalent, the x is my cosine and the y is my sine. So do I have my cosine and sine to plug into the formulas now? Yes. So for cosine, I'm going to plug in what? Negative square root of 3 over 2. So I come over here, I'm going to plug in. Where it said cosine of negative 7 pi over 6, I'm going to plug in negative square root of 3 over 2. And then I'm going to multiply. A negative times a negative is a? And 10 divided by 2 is? So my x is 5 square root of,
Over 2.
why would it be 3? Oh, it is 3. We'll see it though.
See?
We'll see it though. I just forgot the little curve on the bottom. Can't even tell. Alright, so now I can do y, and y is negative 10. Put it. Check it. Times the sine of negative 7 pi over 6. And what did we find out the sine of 7 pi over 6 was? 1/2. So negative 10 times, it's a positive half, Don, because it's in the second quadrant, so your y's are positive. Is what?
It's going to be negative 5.
So there's my x and my y. Bless you.
Somebody being, you know, like, thank you.
Good, bro.
I didn't know if it was real, but I went with it.
You finna start up a car.
All right, so that, did we use a calculator?
Hey,
No, but if it was a calculator part and it had like 3.6 or something, literally in the calculator, you're taking this portion and plugging it into the calculator. So I would go to the calculator and I would put in negative 10 cosine of negative 7
Divided by 6.
pi divided by 6 and round that to the nearest hundreds, and that would be my answer for my x value. I can arrow up, hit enter, and delete out the word cosine and type in sine, and that would be my y value. Okay? Calculator part literally means put it in the calculator. Do nothing else but put it in the calculator.
So 5 square root of 3 equals 8.6.
Yes, it's approximately 8.6. It doesn't equal, it's approximately 8.66. All right? Do you see why we don't have calculator practice on the review? Because it's common sense to just put it in the calculator. Got it? All right. Are there any questions about the calculator portion of your test? All right. Oh yes, you have to make sure your calculator is in what mode?
Radiant.
Radiance. Dock. Settings. You gotta make sure it's in radiant mode. Alright, are we ready to go on? Alright, so on this part, what we're doing is we're now going from rectangular to polar. Okay, so I'm going from rectangular coordinates to polar coordinates. So I have my x and my y, but I want to find my radius and my angle. Okay, so if I'm going from rectangular to polar, what are the two formulas I use?
X squared, no, X.
R equals square root of x squared.
Okay, now what I want y'all to be careful, because I noticed while I was grading some of your quizzes, some of you guys forget to take the square root of r squared. So that you can remember, if you just remember it as r equals the square root of x squared plus y squared, that'll save you in the long run.
Can you also do x squared plus y squared equals r squared? No, r squared, because you have to square, you know what I'm saying?
No. I don't know what you're saying.
You know what I mean? X squared.
You understood it, Adam?
Yeah, r squared equals x squared plus y squared.
That's what I just said.
Instead of square root it though.
That's what I'm telling you, because you forget to square root it and you need to square root it. That's why you should just keep it like this. R squared equals x squared plus y squared is easier to say and verbalize, but you forget to take the square root and your answer becomes wrong. That's why I'm telling you, you should memorize it this way, so that you can remember to take the square root. Okay, and theta equals the tan,
Tangent of negative 1.
the arctan of negative 1 y divided by x. All right, so those are the two formulas that you need to know for this portion of the test.
So I'm guessing we're going
On
to get a
tomorrow.
decimal answer for the first one.
Huh?
We're going to get a decimal answer for the first one.
No, it's not calculator.
So x would already, r would already equal 5.
No, r does not equal 5. Okay, so r equals the square root of 5 squared plus negative 5 squared. So r equals the square root of 50. Equals 50. 5 squared is 25. Negative 5 squared is 25. And 25 plus 25 is?
50. Maybe he didn't finish.
Wait a minute. If a positive is with a negative.
When you square a negative, it becomes a positive.
What I'm saying, okay.
When you square a negative, it becomes a positive. Because remember, a negative times a negative is a positive. So 25 plus 25 is 50. All right, this can be reduced. You will lose points if you do not reduce. Okay?
That's all you have to do.
Square root of 50 can be, yes, define the radius. All right, square root of 50 can be reduced. All right, square root of 50 can be reduced. You hear me? It can be reduced. You either can reduce it like this and get that r equals 5 square root of 2. Or you can go back to 5th grade when you learn how to do prime factor trees. And you have 50 and you find it, and I'd say 5 times 10. 5 is a prime number, so I leave it alone. And then I have 5 times 2. Now everything is prime. Everything that has a pair can go outside. Everything that doesn't stays inside. Okay?
So we keep the square root and everything.
If it doesn't have a pair, it stays inside. If it has a pair, it can go outside.
They're just going to confuse them, just let negative 20, square root of 25 times square root of 6.
This right here is factoring it. I can separate square root of 50 into a perfect square, right? The perfect square that resides as a factor is 25. So I can have square root of 25 and square root of 2. What's the square root of 25? Is there a square root for 2? A perfect square? No, so it stays on the inside. If you're not good with multiplication, sometimes the prime factor tree makes more sense. Okay? Like, okay, let's do another
What is the
one.
point
So I'm
of square root
concerned.
of 2? Because square root of 25 is 5.
Yeah, but 25 times 2 is what gave me 50.
Oh, okay.
Okay, let's try another factor tree. If I had the square root of 45, is there a perfect square in 45? 9. And what would times 9 to give me 45? 5. What would times 9 to give me 45? Okay, so this becomes what? Square root of 5. Or, if I'm not good at knowing my multiplication, I just know the basics. Like, I don't know what else you would know besides 95, okay? At that point, I just don't know what to tell you. But where there's a pair, they go outside, and when there's no pair, it stays on the inside. It's going to give you your simplified radical. So y'all left algebra 2 not knowing how to simplify radical?
Basically, you know.
I had Mr. Philly. What to do?
Is that a 3 or a 2?
A 3. I told you sometimes my 3s don't go all the way through, Dawn. Gosh, the answer's at the bottom. All right, so that's radius. The radius is fairly easy to find. If you struggle with finding the radius, guys, if you struggle with finding the radius, please stay after school, and we'll practice. Okay? Now we're going to move on to finding the angle. So finding the angle, the formula is, I hope you're talking this much to your test tomorrow. To yourself, because you know what to do. So, that's how to find the theta. So I'm going to plug in y and x. Y is negative 5, and x is positive 5.
I got -0.7.
Why are you touching the calculator?
I didn't touch it. I just like.
I got 7.
Okay? Alright. So, what happens here is that what this tells you is you need to figure out where would this value lie? Where does this point lie?
Quadrant 4.
What quadrant does a positive x and a negative y lie? It lies in quadrant 4. It lies in quadrant 4. I'm glad you asked, AJ. Notice here that this is when x is positive. Positive x. You said y. Is it 4?
No, I said I got my Y's mixed up.
Oh, okay. Sorry, I heard y. So we would lie here.
So what would be the answer? I don't wanna look at it, you know what I'm saying?
Okay. So I need to know what y divided by a equals -1. 7 pi over 4. Because the number divided by itself is 1. And it's already negative, so it tells me that it's negative. So my angle is 7 pi over 4.
Ms. Jones, I have a question.
Guys, please do your review. I'm not. I'm gonna post this.